Hi, my name is Judy Craig, and I work for Lancaster Lebanon IU13. I'm the non-public STEM consultant. This presentation is about block coding with virtual Ozobots and Ozoblockly challenges. You do not need to have an Ozobot to learn how to block code with an Ozobot. Since I wrote my proposal, they have come out with a new Ozobot challenge called Ozotown, and I am excited to share that with you. Let's get started. The things we're going to go over in the next 45 minutes are the three Ozoblockly games or challenges known as Shape Tracer 1, Shape Tracer 2, and Ozotown. If I have time, I would also like to go over the Ozoblockly editor and where to find Ozoblockly lessons. If you were able to attend my 2 ways to code, you will see that some of my slides are similar, but I have in-depth information about these Ozoblockly challenges, which I did not have in my first presentation. As you can see, ozoblockly.com is fun and easy for students to jump right in and start playing. This is a picture from a playground that I had at an event at IU13 where students could just come in and start learning about Ozoblockly. It's not if the technology will fail, it's when, because it's constantly failing. Either the computer or the internet or the devices themselves. So, what I do is I always begin my lessons with explaining the concept of failing forward with my students because as they get frustrated, we just refer back to it. You try and you fail, and you try again, and you might fail again, but you keep trying until you succeed. No one ever wrote a code for their favorite video game and had it completed the very first time. They always fail at least once. So that is something that will help students get through their frustration. Now, when I first started playing with Ozobots, I thought, these are fun, but what educational value do they have? Then I started looking into the ISTE standards and found that computational thinking goes hand in hand with coding. Programming tells a computer what to do, but you have to have a human who thinks computationally to be able to figure out to tell the computer what to do. These are the four cornerstones of computational thinking. If you want to know more about it, you can check out the link at the bottom of this screen. What's an Ozobot? There are two different types of Ozobots. The first one is a bit. This is my favorite one, but the problem is they're out of production. The company really is pushing their Evo product. It's twice the price. It does everything a bit will do. You might be able to find a bit on Amazon or Target or Walmart, especially around Christmas time. They're about $50. They have optical sensors to be able to read the codes, and they have one light. The Evo is more readily available and it's about $100. It has 7 lights, proximity sensors, and a speaker. Anything that you can do with a bit, you can also do with an Evo. The most important thing you need to learn how to do first is how to calibrate an Ozobot if you're actually using one. Because again, you don't need an actual Ozobot for the virtual challenges, but you might want to have one anyway. For Ozoblockly, instead of using a black dot, you would use a white dot to calibrate it to the screen, but you would use the exact same method. Now, how is computational thinking? related to coding with block coding? Well, decomposition is the blocks that you use, choosing them. Pattern recognition would be learning about looping, which we'll be talking more about today. Abstraction would be ignoring anything that will not lead you to where you want to go. And algorithms is the entire process of debugging and running the program again and again. So these are the three types of challenges. Shape Tracer 1 and 2 are really for younger students. Shape Tracer 1 is beginning coding with concepts of sequencing and debugging. In Shape Tracer 2, they add loops, and Ozotown, which just came out this summer, is more directed at middle and high school students. Shape Tracer 1 and 2 can be done even with a second grader. Now, what I have on this next slide is a link to Ozo Shape Tracer 1. And I have Shape Tracer 1 lessons and the basic block coding because Ozobot has come up with lesson plans specifically for Shape Tracer. So let's start by going to Shape Tracer 1. If you can, if you have a second device or a second screen and you want to do this now, you can, or you could do it later. This is Shape Tracer 1, and let me just show you around the editor. It has up here a goal. You click on that and it tells the student exactly what to do. This says get the Ozobot to trace the line shown in the bot simulator. That's what this is over here. This is why you don't need an actual Ozobot. This is your virtual bot here. Add a light effects block and set the bot's light color to match the line. This line here is green. Add a movement block and adjust the steps. Then it gives you a clue. One simulator square equals one step for an Ozobot. So we can see these are sets of 5, so there's 10 squares altogether. Sometimes I don't even have the kids read this. I have them try to figure this out on their own. If you click the goal again, it will go away. Now, something that's important that students don't often know is that you have to set the light color first. So I'm going to get rid of these and start again and kind of show you how this works. We have the blocks that are needed over here. If you've ever been in a block editor before, you might have noticed that there were many more options. Well, they only give you the options that you need. So there's a movement block. We can grab that and drag it out onto the editor. There is a light block. We can grab that out, drag it out onto the editor. The light block, if you click on the color, you can change it. And we know we want this one to be green. We know we want our Ozobot to move forward, and we've determined that it's 10 steps. So we have forward. There are many different options. Oh, nope, only 2, forward and backward. And steps, we're going to click 10, and it doesn't tell us the speed, but kids like to see it go fast. So I often click fast or very fast. Now, the important thing is that you click these 2 blocks together. You'll hear the click. Okay, this is an undo and a redo button. This is a copy, and this is a trash can. Okay, the kids will immediately know that. Now, once you have this set, you go over here and click on the Run button, and let's see what happens. Oh my goodness, excitement. It has been done correctly. And then it says that you could actually load your Ozobot if you wanted to. So here is a spot where you can actually load it onto your bot. It dragged down this from looking up here down to here, and you could calibrate your Ozobot, place it on here, and load it, and it will start doing the disco lights. And if your Ozobot is flashing green during that time, then it has loaded. If not, you can try again. But again, you don't need an Ozobot to play this. Now, let me show you if we made a mistake. Let's say we did the color second. Okay, what would happen when we run? Oh, maybe the student would notice here that this is a white line, not a green line. Okay, it doesn't give them direction. They have to debug on their own. Reset and try again. There we go. And this will then lead them to level 2. Now, that's all fun to play with, but let me show you the shape tracer lessons that they have come up with. So I'm back in my presentation and I'm going here. This will take you to the basic lessons. It explains how to flash load if you want to do that. It talks about Shape Tracer 1 and it gives you a link. And it tells you that even though this is called completely virtual programming, levels 4, 7, and 10 do not have the ability to double check your to run your code. So you might need an Ozobot for that. So if you're working on this virtually and you have one, you could always do that with your students, possibly on a Zoom call or a Google Meet or whatever platform you use. But all of the other levels, you do not need an actual Ozobot. There is a tutorial for level 11 where they'll actually create their own challenge, and then there's a board game that's attached here that you can play. So this gives you step-by-step lesson planning, and it says it'll take between 3/4 of an hour and an hour. It gives you vocabulary. Here is the guided class activity. It walks you through kind of what I just explained with level 1. Level 2 is very similar, except you add a rotation button, and it talks about explaining the difference between 45-degree angles and 90-degree angles. We can integrate that right into math class. Then levels 3 to 10 show other coding aspects. There's an independent activity, as I mentioned, for level 11 and a game. Now, here's the best part. They have the answer key for all 10 of the levels. Okay. So you don't have to be wondering, am I doing this correctly? Okay. This is a handout for that optional create your own shape tracer level. And then this is the board game. I love how they've added these lessons to help you along. All right. I also wanted to let you know that during our shutdown back in March, I didn't really have much to do that very first week. So I went in and created 12 videos. The first one explaining how to get to Shape Tracer 1, and then how to do each of the levels. And then the last one, I think that is about how to create your own. I didn't get to do Shape Tracer 2 yet, or Ozotown since it just came out, because as soon as the second week came in the shutdown, I got very busy, as I'm sure you did also.
3 minutes, here we go.
All right, now let's take a little time to look at Shape Tracer 2. This will link us right to the website, and here are the lessons. So let's go to the website first. All right, you'll notice the goal here is in the same place. This one is asking you to trace the shape in the bot simulator on the right over here. One step for Ozobot. Add a light effects block and set the bot's light color to match the line. Add other types of blocks to trace the shape. Can you use the loop to trace it with fewer blocks? Now, this is where looping comes in. And there's a great explanation in the lesson, which we'll look at in just a moment, that kind of shows kids how to do this and then how to do it even in an easier way as coders do it using loops. This also has 10 levels, which unlocks a game at the end. Notice there's more options over here. Movement blocks, light effects, but then there's also loops. As you go through the levels, they may add, let me see if they ever add anything more than loops. No, I don't think so. Okay. But the challenges become more and more difficult, just as they did in level 1. The editor is still the same with an undo and a redo button, a copy, and a trash can. So let's take a look at the lessons for Shape Tracer 2. Again, this was created by Ozobot. Okay. It explains how you're going to learn more about movements, forward and turns, loops, nesting loops if you'd like, and light effects. There's also a create your own tutorial level and another game. So this gives you the lesson plan with vocabulary. Here's the first guided activity to get your students through level 1. And this might be what most of your students create. And this is how you can get into an explanation of looping, because you'll see that many of these blocks are similar. So you can talk to them about how to add a loop, to use less blocks. As it continues on, there are options. Let's see, level 2 involves the same skill. Level 3, figure out a puzzle. Oh, you could do this as a group activity if you'd like. You can also include nested loops. There's a YouTube video here to go to and share with that. This could be a multi-day activity. Here's showing you step by step how to do nested loops. And again, levels 4, 7, and 10, the simulator is disabled and you are to use an actual Ozobot. So having one Ozobot on hand might be something good to do with all of your students, again, in a group call when you can pull everyone back together. There's the independent activity and the shape tracer game. Again, we have all of the answer keys for you. The independent activity and the game. All right here for you.
Three minutes, here we go.
take a look at Ozotown. This is the third challenge available in the Ozo Blockly games, and this one is created for middle and high school students. This doesn't have any lessons to go along with this, so I thought I'd take you through the first couple levels and then give you a chance to play yourself. Let's click here on Play Now. Okay, again, the editor is set up in a similar format with the goals, all of the steps. Here are the different options for blocks, and over here is the simulator. Down here is where you can run. All right, so the first one, let's look at the goal. Use Ozo Blockly code blocks to program Ozobot to travel home. The line navigation, we only have one option for a block, and I already pulled one of those out. Follow line to the next intersection or line end. That looks like it's going to take me right to the line end, so let's run it. Okay, wow, that was a little loud. There's an option here to load it onto an actual Ozobot if you want. Let's go to level 2. This one, the goal is program Ozobot to travel home without making any extra stops. And in my line navigation, I have 2 blocks. I pulled one of each out. Follow line to the next intersection. Okay, so I'm going to do that. And then I have to pick a direction for it to go. My drop down offers left, right, straight, or back. So I'm going to go straight. But that would only get me to here. So I wanted to go on to the next intersection, so I made a copy of this first block, and I can do that by either right-clicking and hitting duplicate, or I can click on that block and hit copy. Now I don't need that one, so I'm going to throw it in the trash can, or I could have right-clicked on it and deleted it. Right, let's run this and see if it works. Okay, let's go to level 3. The goal is to program the Ozobot to travel home without making any extra stops. This time, look out for speed signs to see if you need to set the line following speed at the beginning of your program. Okay, here we have a speed sign. There are several arrows. Only one arrow is highlighted. So when I go into navigation, I have 3 different types of blocks. I've pulled out one of each. Follow the line to the next intersection, but I have to set the speed first. So I use the speed block, and these are my options. Since I only have one arrow highlighted, I'm going to assume that means slow. Then I'll follow it to the next intersection. And at this intersection, I'm going to want to turn right so that I can get to my home. Now, sometimes students get a little confused about, well, which direction should I go? Tell them that they can think of their virtual Ozobot as something that they are driving. So if they're in the car driving, which way would they want to go? So they'd want to turn right. These are my different options to turn. And then I know I need to propel my Ozobot forward, so I wanted to follow the line to the next intersection. I'm going to run this again. And there we go. Now there are several more challenges for you to try, so I'm going to give you a few minutes to go ahead and do that on your own.
Three minutes, here we go.
if you haven't done so already, you're definitely going to want to go to this link and download your own copy of this presentation, because the next 3 slides have videos that explain step by step how to use the Ozo editor. First, there is a video created by Ozobot that walks you through how to use the editor. I then created my own, which is slightly shorter. And after that is a 1-minute video of how to connect your Ozobots to your Evo app. So I'm just going to click through these 3 slides quickly, and then we'll move on to our next phase of the presentation. If you watch the Ozo Blockly videos, they show an explanation of how to get students started on downloading the code onto the actual Ozobot. And this is the screen that I usually use to help students learn how to do that. So that's what this is. Then, if I have any students who are excelling, I may ask them to go to the next step of creating a rectangle walk, which requires a lot of computational thinking. The last thing I want to share with you is how to navigate the Ozobot classroom, which is where you are going to find lots of lessons on using both color coding and Ozoblockly. There is another great website called ed4tech.com that has great lesson plans too. The next screen is another video you'll want to check out that will walk you through how to navigate getting the Ozobot Classroom, which is free, and using it to find and store all of your own lessons. Lastly, I have just a few resources for you. This one has a link to 3 different bot camps that walk you through what your robots are, how to color code, and how to block code. This is what I used to learn how to use my Ozobots. This is a hyperlink doc that Nadine Gillickson created that I have posted in this presentation, because maybe there's some more great tips for you. And that's all I have for you today. What I would like to do is go back to the very first slide so that you can see my name and my contact information. You can email me with any questions or find me on Twitter and tweet questions to me. Thank you so much for coming to my presentation.